In this video, we are going to discuss an algorithm to perform a linear or sequential search. You're going to see that this algorithm does what we do in real life. So for example, if you leave your wallet in your bedroom, you start looking in a certain order. You look under the bed, you look in your drawer, you look under the pillow, and you keep looking, moving from one place to the other until two things happen. Either you all of a sudden find the wallet, in which case you stop looking for the wallet, you already have it, or you are going to move to a different place. You went everywhere else, you went everywhere where you could go in your bedroom, you didn't find it. So now you say, well, maybe it's in the car, maybe it's in the garage, maybe it's in the yard. You go to a different location. Eventually, you're going to decide to stop if you didn't find a match. The algorithm for linear sequential search works the same way. So what we're going to do is take a collection of values. Typically, that collection is stored in an array. It's very important because an array has indexes. Also, because we're familiar with arrays, we know that the first index on the array is 0. So it's very easy to find the first value in the collection, the first value in the array. Also, we can determine very easily in Java how many elements we have. So we know where the last element is. So once we reach the last element and that one is not a match for the value that we're looking for, we can stop the search and conclude that the value that we were given is not present in our collection. So the steps are very simple. Again, you start with the very first value. You determine if that value is a match. There are two possible outcomes. It is a match, in which case we're done. You found your wallet. No need to keep searching. But most likely, you're not going to find a match at the very first time that you compare the two values. So it is likely that there is not going to be any match. Then what do? You move to the next element in your collection. Remember, we're talking about arrays, so it's very easy move from element to element because all we have to do is to change the index of the element. And indexes in Java in an array, they increment in values of 1. Finally, we need to repeat this process, meaning access one element, compare. If it's not a match, access the next element, compare, until we either find a match or we inspected all the elements in the array. We traverse the entire array and there are no matches. So let me give you an example. So here is the collection of numbers. It could be a collection of any objects. Notice that the collection is in random order. This is not in any particular order. In other words, it is not sorted. So the task is to determine whether or not 65 is in that collection. So what do? Well, the first step is to start with the first value. In other words, we're going to access the first element in the collection. We know that that is the one with index 0, so it's very easy to locate. And then we're going to compare 45 with 65, where obviously they are not the same. There is no match. So what do? We go to the next element in our collection. That happens to be 3. And now we compare 3 with 65. And again, they are not the same. So we go to the next element in our collection, which is 15. And again, 15 and 65 are not the same. So as you see, we move through the array, sequentially, linearly. We don't skip any elements. We don't jump to the middle of the array. We just go one by one, comparing the first element with the key, the second element with the key, the third element with the key. Finally, the fourth element has a value that matches the value that we're looking for, 65. In which case, we got a match. You found your wallet. Therefore, the algorithm should stop. There is no need to search the other numbers. We already found a match. And furthermore, we know exactly where it is. We know the value of that index. The value of that index is index 3. Remember that in Java, the indexes start with 0. So 45 is index 0, 3 is index 1, 15 is index 2, and 65 is index 3. This is important. Why? Well, because it's not enough to say, yes, 65 is in the collection. What is important and more useful is to know where in the collection 65 is located, if it is there. Okay? So we need to know that the index of the element is 3 and that has the value 65 that matches the value that we're looking for. There is a second video called LinearSearch Code that I encourage you to watch after you finish watching this video. In that video, I'm going to discuss the code, the implementation for linear search, and you're going to see how the method that does the search actually returns the value of the index if there is a match. Now, let's assume that we have a different collection of values, like this one here, okay? So now we have 8, 34, 12, 5, and 9, and our task is to find 14. So the technique is the same. We start with the first value, compare the first value with the value we want to find. They are not the same. Go to the next one, they are not the same. Go to the next one, they are not the same. Go to the next one, they are not the same. And go to the next one, and they are not the same. 9 and 14 are not the same. But now, the algorithm will realize, oh, this is the last value in the collection. I look everywhere in my bedroom and I cannot find my wallet. So what do? Well, we don't go around looking again. We know that it's not in the bedroom. We go to a different place. Well, here, the algorithm will stop because it has inspected every value in the array and did not find any matches. In this case, you're going to see that the value returned by our method is -1. Why is it -1? Because remember, we're interested in the location. If there is a match, we want to know where it is. We want to know the index. What happens when we don't find a match, like in this case? Then we want to return an index value that will indicate to us that the value that we're looking for is not present in the collection. And in Java, that value is -1. So again, the algorithm that we're using will return -1 to indicate that there are no values that match 14 in our collection. I encourage you to watch that video called Linear Search Code, and you will understand better this issue about the -1. So, it's a very simple algorithm in the sense that it starts at the beginning of the collection, and one by one is going to compare every value until either it finds a match or we run out of values to compare. The more values that we have, the longer it's going to take to arrive to a final determination. So remember, you need to think about large data, 100,000 values. So we may need 100,000 tests to conclude that the value that we're looking for is not there. Or we may need less than that. So the expected running time of the algorithm is proportional to the size of my data. And that, we said, is O of n. Again, don't worry about the meaning of O, it's just a notation. What is important is to understand that linear search is directly proportional to the size of our data. The bigger the data is, the longer it's going to take for us to find the values. Okay? The other analysis is pretty simple. All we're doing is, starting from the beginning of our collection, compare the values one by one in sequential order, linearly, from the beginning to the very last one. Obviously, this is going to require a very large numbers of comparisons. This technique will work in the sense that either it finds what we're looking for or it will not, but it's a very time-consuming technique. I encourage you to watch a different video called binary search, which utilizes a different approach that is much faster than this one, but it has some conditions that needs to be met.